Okay, next up we want to compare the number of neutrons in potassium 39 and potassium 40. And so we need to understand that these numbers are the atomic masses. So let's actually write down the full name for both of them. So include the number of electrons. You know that potassium has 19 electrons. You can find that out by just looking at the periodic table too. So the atomic mass is caused by adding up the masses of the neutrons and protons that you have. We ignore the electrons because in the model that we currently have, electrons are known to be very, very small compared to the nucleus that contains these neutrons and protons, and so its mass is negligible compared to the neutrons and protons. And if you simply Google neutron and proton masses compared to electrons, you'll see that the numbers work out for it to be negligible. And so what that means is if I have 19 electrons and the element is neutral, then that means I have 19 protons too. And so to find out the number of protons in both of these, I'm simply going to, the number of neutrons in both of these, I'm simply going to take away the 19. And so 19K39 has 19 protons and 39 minus 19, and that will give me 20 neutrons. Potassium 40 also has 19 protons and 40 minus 19 neutrons, and that is going to give me 21. Let me just ensure I'm getting the right numbers here. Yeah, and so we can see that these two are something called isotopes. And what that means is that they have the same number of protons, but they have a different number of neutrons, evident by what we've just calculated here. And so common examples of this would be C13 versus C12. C12 is common. It's most of the carbon atoms that we interact with today. C13 was common before, and so C13 is used for spectroscopy and it's used for carbon dating too, because if you find out the amount of carbon-13 present, you can find out how old it is. And that's it for this question.